Okay, so at the start of the filming of this problem, it's about 2:30 a.m. local time. I'm going to try to get through as many of the AMC 12 problems as I can, up to about 15 before I call it a night on that. But I don't know. I might only get to 10, and you might have to get the other ones later on in the day. We'll see what happens. The national debt, I've got work later as well. I got to teach, and I don't want to be exhausted. I'm going to be cutting it close to like 6 or 7 hours of sleep, and I don't want to go any less than that. The national debt of the United States is on track to reach 5 times 10 to the 13th dollars by 2033. How many digits does this number of dollars have when written in base 5? First off, that's a lot of debt. You want to go down a rabbit hole, go look into how we get our debt and what all that is, and it's kind of fun. I won't go into more details. I wouldn't call it fun. It's kind of worrisome. How many digits does this number of dollars have when written in base 5? The approximation, and they tell us this, the approximation of log base 10 of 5 as 0.7 is sufficient for this problem. And they probably intended for you to use that, but it's almost like a hint, like, hey, why don't you use log of base 10 of 5? And I suppose you probably could. I'm not going to, but you probably could, and probably this even the better way to do it. But if you know other ways, I don't want to mess with the log or the 0.7 or anything. Let's just look back at this. How does different bases work, right? If you could convert this to like 5 times 5 to the 13th times 2 to the 13th, then this would be 5 to the 14th. Okay, times 2 to the 13th. Well, if you just think, okay, well, how many powers of 5 is the 2 to the 13th? And you might know that 2 to the 11th was the famous game 2048. And so to get to 2 to the 13th, you're just multiplying by 4, which happens to be the highest tile that I ever got in the 2048 game before I moved on with my life. That game takes like hours to play to get to that point. 8192. And so you say, okay, well, where's that relative to 5? I don't know. What's 5 to the 4th? 625. What's 5 to the 5th? 5? You can tell it's late. 3125. And you say, well, what's 5 to the 6th? I mean, you're already at 5 to the 5th. If I multiply by 5 to the 6th, I'll be at least 15,000. Whatever that is, definitely more than this. So you know that 2 to the 13th is less than 5 to the 6th, but greater than 5 to the 5th. So now if we just take that, we know it's more than 5 to the 5th. This number is at least 5 to the 19th. I'm just going to call it x, and less than 5 to the 20th. To get to 5 to the 20th, I would need this to be at least 5 to the 6th, and it's not, right? We proved that here. So therefore, if you understand how bases work, right, if I have like 1 times 5 to the 3rd plus 2 times 5 squared plus 1 times 5 to the 1st plus 0 times 5 to the 0. That's 1210 base 5. Well, basically the largest power of 5 that you can fit will kind of determine what you get. You'll notice that you get 3, 2, 1, and 0. So even though it's 4 digits long, this is not 5 to the 4th. Okay? It's 5 to the 3rd. So now if I think about it, I've got at least 5 to the 19th. And so you would go 19, 18, 17, all the way down to 0. And from 19 to 0, there are 20 digits. And I don't know, maybe you enjoyed the log. I thought I'd dodge it. Like I said, always kind of been a rebel. Do it my own way. Okay, and so now for problem number 11 on the 10B, which was 7 on the 12B. In the figure below, WXYZ is a rectangle with WX equal to 4, not labeled, WZ equal to 8. Go ahead and label it. Point M lies on XY. Identify it as you're reading. Point A lies on YZ, and angle WMA is the right angle. Those are all marked for you. The areas of triangles WXM, this one, and WAZ, this one, are equal, what is the area of triangle WMA? So my suspicion is that you can solve this by calling this like X, and you could put Y up here if you wanted. I'm going to put it here for reasons I'll get to later. I don't actually know why. It's what I did in my problem when I solved it. This is just the way I solved it. You might have found a quicker way again. Not all my solutions are most efficient. So I called this 4 minus Y. Now, again, I probably could have called that Y and this 4 minus Y, and maybe it's better, but that's not what I did. So anyhow, what you could do here, I bet you could just do Pythagorean. For instance, this will be 8 minus X, and I bet if you do this squared plus that squared square rooted, and then this squared plus that squared square rooted, and you did something with that, I bet you could find the area, you know, without having to actually find X and Y is my suspicion, but that's not what I did. I went ahead and you could explore it for yourself and see. I just went ahead and set the base and height X times 4 and this times that must be equal. So 4X has to equal 8 times 4 minus Y. And so you get 4X equals 32 minus 8Y. Probably should have just divided by 4 first. That would have been smarter. X equals 8 minus 2Y. So X plus 2Y equals 8. So now I just said, well, this whole thing's 4 and that looks bigger than half. What if I just guessed that this was 3? And that's what I did. You could do other things, I suppose. I could probably replace the X and the Y and do a bunch of algebra. But sometimes you take gambles just to see if it works out. And that's what I did. I said X2, Y3. That does make 8. Let's see if it works out. I'm going to replace this with a 2. This would then become a 6. This would be a 3. This would be a 1. Then square 8 squared plus 1 squared is root 65. That's your hypotenuse. 16 and 4 is root 20. 36 and 9 is root 45. So the deal is that's a root 45. I'll write nicer, maybe a little bit nicer. Okay, so root 45. That squared plus that squared equals that squared. That's exactly what we needed to happen. Would it have worked for other values? Maybe. Explore the problem yourself and see. Did I get lucky? I don't know. I suspect that it doesn't maybe matter what the values are specifically as long as that was true. Maybe I'm wrong. Find out. I don't know. But it worked out. And as long as it works out, we don't care. That's the thing. You don't have a limited time. You don't have time to prove every possible way to solve it while you're solving. And I certainly didn't wish to establish whether or not multiple values could be used. But let me know in the comments if you found another way. That'll help other people out. So then what now? It wants to know the area of this triangle, which is simply going to be root 20, which is root 5 times 2, times root 5 times 9, root 9, and then that's going to be 3 times 2 is 6 times 5 is 30, and then you'll divide that by 2 to get answer choice C, which is 15. So basically the root 20 is root 4 times root 5. I saw the 2. Here I was trying to make it the right way, but I just didn't. I wrote it the wrong way. I should have written 3. So 3 times root 5, and so 3 times 2, 6. Root 5's multiplied gives you a 5. 6 times 5, 30. Why are we dividing by 2? Half base times height. I'm sure you'll understand that's why the answer is C. Let's get to the next problem. And no test would be complete without some log problems. So let's get a look at it. 12b problem 8. What value of x satisfies this? Now you might think to plug in answers, probably shouldn't. Not going to be a fun time for you. You're just going to be, it's going to look weirder, trust me. What I did is I just looked at this and said, I've got this thing, and they look a lot alike, and they are the same thing, and this are the same thing, and one has a times and one has a plus, and I furthermore hate these things. I don't want to look at them anymore. Could I replace them with something that makes my brain not hurt as much? Maybe I could just do some algebra with something simple, because what we have conceptually is a times b over a plus b equals 2. And then I looked at this and I said, oh, I wish if these were a product, I could cancel something, but they're not a product. But wait a minute, what if I flipped it upside down? which you can do because it's called a reciprocal and you're allowed to do that as long as you do it to both sides. Let's go ahead and do that. Now, as I'm flipping it upside down in my mind, I'm picturing the AB underneath and I'm splitting it, right? A over AB plus B over AB equals 1/2. Now, I don't write this on my paper because I've seen enough things like this that I can more quickly just cancel the A, and I'm going to get 1 over B plus 1 over A is 1/2. And then I look back at these things and I like, oh, this base and that base are both things I wish were the same, and they're not the same, but we can fix that because the arguments of the logs are the same, and there's a great rule to do that. It's a small notebook concept. Log base B of A is the reciprocal of log base A of B. So if I thought about log base x of 2, log base x of 2 would equal 1 over log base 2 of x by that rule. So now, you can use change of base formula to prove that, by the way. But for now, I'm not going to do that because what we're looking at is, we're looking at this, 1 over 8. That's what this is. So we're basically going to get log base x of 2 plus log base x of 3. This 1 over b is the reciprocal. It's this. Like this is like this is my a. 1 over a equals log base x of 2. You understand what I'm doing? So I'm putting back in now the reciprocals of these, which are the other two numbers, and that's still equal to 1/2. Now that our bases are the same, this plus sign, these get combined into one log. It becomes log base x of 6 equals 1/2. You just multiply the arguments to do that. X to the 1/2 equals 6. I call it smiley frog face because it looks like 1. X to the 1/2 is 6. X is 36. Let's go ahead and get to problem 9. And here we get another small notebook concept appearing on the test. So if you were in that class, I really hope you caught this and were able to put it to use immediately. It's just a diamond graph. A dartboard is the region B in the coordinate plane consisting of points x, y, such that this expression, absolute value of x plus absolute value of y, is less than or equal to 8. If you took my class, this is a diamond graph whenever you have this, and the distance from the origin on the axes is 8. Let's go ahead and graph that. So you're going to go over here, you'll go up to 8, -8, 8, -8, and it's going to go like this. Now, you're inside of that region less than or equal to, so it'll be inside of there. There's 8 and 8 and -8 and -8 here. Okay, now a target T is the region where this is true. Notice it's something squared and you got a perfect square. You're probably square rooting. A dart is thrown and lands at a random point in B. The probability that the dart lands in T, this region, can be expressed as. Stop there, go find T. Okay, so now you're going to square root. When you square root a perfect square, you get the absolute value of that thing. Earlier in this test, we did cover the absolute value aspect, that if x is less than c, it simply becomes less than c and greater than -c. So because of that, you can blaze through this. You're going to square root both sides. It's going to be 7 and -7. You're going to get x squared. That's small notebook concept as well. X squared plus y squared less than or equal to. It's -25, but you're going to have 7, right? So this will be a 7, and you're going to be adding 25 to it. You're going to get 32, and over here it would have been -7, and you're going to be adding 25 to that, so you get 18. When you're trained, you can just go straight to there from that point because you recognize what is happening. All right, so now a dart is thrown and lands random point, blah, blah, blah. We want to know the area of this region. Well, that looks an awful lot like a circle. X squared plus y squared equals. What does the less than do as an effect? It means you're going to be inside of the circle, whereas for this one, you're going to be outside of the circle. So what we're looking at is concentric circles. They're both centered on the origin. One of them has a radius of 4 root 2. The other one has a radius of 3 root 2. But we actually don't really care. We don't care what the radius is. Well, I take it back. We actually do care. Because the outer radius for root 2 is going to be this right here when you go perpendicular to that. So since this is 8, that's 4 rad 2, which means your outer circle does fit inside the diamond graph. I thought we wouldn't care, but we probably should care and check to be certain. So that's your outer circle, and then the inner circle here would go whatever, 3 root 2, something like that. That is the area it wants, the donut region. So how would we get that? It's simply pi big R squared minus pi little r squared. You factor out the pi. What's capital R squared and little r squared? They're these things right here. 32 minus 18 is 14. And you're going to have that over the area of the grid over here. It's just 8 root 2 and 8 root 2. So 64 times 2, 128. You could do that, or you could just do 64 times 2. We put 2 into 14 to get 7. 2 into 14 to get, hold on, so is it 14? 32 minus 18, 14 to get 7, and 7 over 64 is going to be 7 over 64 pi. Now, just really quick, we also could have said 8 times 8 is 64 over 2 is 32, and you would have 32, 32, 32, 32, 432 is 128. Just double checking you're not making any silly error or anything like that. 7 plus 64, is that what it wants? M over n pi, that's what we have, where m and n are relatively prime. That means they have no common factors. It does not mean they're prime. Very common language. If you're new to the test, learn it. Positive integers, what is 7 plus 64? Answer 71. Let's get to the next one. And the last video in 2 different rapid fires, one for the 10B problem 15, the other for the 12B problem 10. This question, it ended up being quite a bit of a time sink for me because I failed to catch certain pieces of reasoning that I had to go back and revisit and then caught. So if you had a significant time drain on this problem, you're not the only one. I did as well. And it's just going to depend how many of your contemporaries didn't have that trouble and reasoned correctly on it right away. If you were on the 10B by the time you got to problem 15, you're probably pretty fatigued. If you're on the 12B, you're probably still a little bit fresh and you might have worked through it a little bit more effectively. So a list of 9 real numbers consists of 1, 2.2, these, count them, 1, 2, 3, 4, 5, 6 numbers, as well as x, y, and z, that's 9 total, with x less than or equal to y less than or equal to z. The range of the list, which is the difference between the greatest and the least, is 7. This plays a significant role in that reasoning, and if you manage to apply it correctly, it probably didn't take you as long as it took some other people who got lost in a couple of the details. And the mean and the median, the average and the middle number, are both positive integers. Because you have 9, it will be one number only. How many ordered triples x, y, z are possible? So your attack point should really be here. And the reason I say that, basically if z is the largest number, is how you want to start, then if z is the largest number, our current range is only 6. We're going to need z to be 8 if z is the largest. So we say, okay, let's say I've got all of this. In fact, let's add up what we have right now. 8, and then you've got 11, and 3 and 2 is 16.8. So all your 0.2s make a 0.8. I don't add things in conventional ways. I just do it as 2, 3, 5, 10, 16, 0.2, 0.2, 0.2, 0.2, 16.8. 8 plus 16.8. Those are your default numbers. You have a total of 24.8 with them. Now, if we add the z value as 8, so I'm going to have to write these, aren't I, to kind of keep track of what's going on. 2.2, 3.2, 5.2. By the way, the next number needs to be your median, which means it's either x or it's y. And so we're going to have to leave a space open for that because we've got 4 numbers right now. who knows what it will be just. It's going to have to be 6. Whether it's x or y, we're not quite sure at just the moment. And you're going to have 6.2, and you'll have 7, and then you'll have 8. So this is either x or y. We'll figure it out in a moment which one it is. So now we add the z8. You're at 32.8. You know one of them is 6. That puts you at 38.8. And we have to add either x, just call it x for now, or it doesn't really matter. The variable's fine. Divided by 9. That's the mean, and it has to be an integer. Why does that 6 have to be there? Because the median has to be an integer, and our current median is this 6.2, which is not an integer. So something's going to have to go right here to become the median. So then what's this sum going to have to be? It's going to have to add up to 45, right? Could x be negative? And this is where if you weren't thinking about the range, you might have thought, well, what if x was negative 2.8? And the first thing you look at is right here, list of 9. Oh, real. Oh, they can be negative. And then you might mess around with that for a while and lose some time before you realize that even if 7 was the largest number, not z at 8, the lowest anything could get is 0. So your negatives can be dismissed immediately. That's a significant conclusion that you wanted to reach, and whether you caught it at the time you were supposed to or not, or it took you a while to realize it, determines how much time we spent or wasted on this problem. So now what? What does it have to be? It has to be able to get up to 45. So you are 6.2 away. Obviously, x would not be the value here. This would be y instead. This would be x on the 6 because y has to be greater than or equal to x. So that makes y 6.2. And so you would have x6, y6.2, z8. We found our first ordered triple solution. Okay, so now what? Okay, did everything get forced after we made this z8? What if could I put the y as the 6 instead and make, no, because there's no way to make this number get lower. It can only go up, and you have to have 6.2 to get there, or you're not going to reach 45. Could it get even higher to 54? No, that would make the other number go over z, and then z would not be the largest number, which it says it has to be in relative to the 3 unknowns. Okay, so what does that mean? It means once z is 8, x is forced to be 6, and y is forced to be 6.2. So the next thing that you would be, okay, what happens if z is not 8? And so you say, okay, maybe then, well, what if we focused on the median? If I make the median between the 5.2 and the 6.2, the only option is 6, and that ends up forcing, that's going to end up forcing the 8 and 6.2 choice as well. So what if now instead we moved x and y over to this side of that line, then y would now become the median, and x would be something less than or equal to y. So could we make y equal to 5? That's the next question we're going to ask. This is kind of like casework, and so we're going to make maybe casework based on what the median is. So if I have 1, 2.2, 3.2, and we're going to make y here at 5, x just has to be less than 5. We don't know what yet. So it's kind of a stipulation. You want to write down less than or equal to 5. We'll just put the x here for now, but it might actually be on the other side of this. If we do that, and you've got 5.2 after 6.27, you don't know, this is why, you don't know exactly where z is. And you don't know quite where x is, so let's just add up what we have. We have our default 24.8. We add y to get 29.8, because y is 5 in this case. This is the y equals 5 case. We'll also try if y equals 4, and we might get multiple values, multiple solutions when y is 5 or 4. We don't know yet. We haven't seen in the future. So then you're going to say, okay, well, I'd have to get to 36 right now. 27 is not possible. I can't have negatives. The lowest anything can get is 0 regardless. So what if I said, okay, well, I need to get to 36. How far away is that? It's going to be 0.2 to 30 and then 6 more. It's 6.2 away. So could I make 6.2 z? Because y can't be past the 5. So if I made another 6.2 here, then what would that mean? That means I'm at 36, but I still have to deal with x. It can get as low as 0. Since z is not playing the role of 8, 7 could be the largest, and then 0 would go here and be the x value. So it wasn't actually over there. And you might double check your calculation. I will not do that right now. 35 and that 36, we're going to have a mean that's an integer, and our median, which is y, is also an integer. You're just double checking, did I do everything? There's a lot of that being careful on this problem as well, which also drains your time. So now what? We've got 0, and then y was 5, and z was 6.2. So now what I want to know is, once the y was 5, this was kind of forced, right? I can't get to 45. It'd be way too big. I wouldn't have a range of 7 anymore. But still ask the question. Make sure you justify why you're not doing that. Okay, so that means once you had this, that's the only solution when the median is 5. So let's go ahead and pick out a median of 4 now. If I do 0, all the same things, right? You're going to have, I'm not going to write them all. I wouldn't write them on my actual test, but for your sake right now, to follow my train of thought, I will. 3.2, you've got 4. And again, x needs to be on that side somewhere. That's y. And then you have 5.2, 6.2. And so you start to see that the real target should be the median for your casework. When the median is blank, 6, when the median is 4, and when the median is 5. And so now what happens? Well, think about it. Where we were just at, the only thing we changed is y to lower it to a 4. So this 29.8 that I was at will now go to 28.8 because you just lowered your y value by 1. Those kinds of thoughts save you time. And so you want to make sure you're trying to think about those kinds of things as you're working. I still need to get up to 35, which means, oh, was it not 6.2? No, 36 rather, not 35. 36. So I have to add 7.2, but I don't know what my z is and I don't know what my x is. Is this possible? And so you say, all right, well, let's say, can x plus z equal 7.2? Well, wouldn't x have to be 0? And this is where you could get yourself trapped. You could end up with a false answer. You say, well, x has to be 0 because the largest is 7, but that means z is on the other side at 7.2 now, and my range isn't 7. How do I fix that? Oh, well, what if I just made z minus x equal to 7? So if I say like z minus x is 7, the range, because making z the largest, then I could replace z with x plus 7. So 2x plus 7 equals 7.2, and that tells you x is 0.1. Now, I didn't do this math on mine. I just looked at it and said, well, I don't know, it just came to me. I just said 0.1 and 7.1 would do it, wouldn't it? And then that made sense. 7.1 minus 0.1 was 7. 7.1 is the largest. You got to keep checking all the little things that could trip you up and get it wrong. And so that's going to move you from the trap answer, kind of a trap answer of 2, to the real answer of 3. Now you still kind of want to go back and ask, is there anything else I could have done? Could the median be less than 4, like say 3? No, there's no way I can put x and y here. Well, now we have to wonder. Let's go ahead and check. What if I put z as 3? And then, yeah, let's check that really quick. What if z played the role of 3 out of curiosity? You can't get lower than 0. What would that do? That would take this 28.8, you're lowering the total by 1, you're down to 27.8, and you would need x plus y, because they have to be lower than z. You're going to need that to equal, to get to 36, you were adding 7.2. Now we have to add 8.2. The problem, even if they're both 4.1, they're both bigger than 3. Now you say, why couldn't y be 3? Because we only have 2 values at the start, and the 5th value is the median. So if I tried to produce a 3 right here, I'd have to have all 3 x, y, and z be less than or equal to 3. And further, this is just past 27, so there's no way I could choose 0 for both of them either. You're going to be trapped. This is good. It makes you think, but the actual answer will be C. Hope you enjoyed it. See you in the next one.